Hello, my name is Pomshin Chan. Today, I will introduce an innovative solution to prevent nanoplastics from penetrating crops using graphene mimicking technology. This picture shows the plastic waste in Korea and Indonesia farmlands. As you can see, a lot of plastic products have been used in the agricultural fields in the various countries. Leftover plastics such as fillings and vinyls are broken down into nanoplastics by physical impacts, such as UV radiation. In this way, nanoplastic in the agriculture field can cause the serious issues. Recently, an Italian research team found the nanoplastics in the apples and carrots. When consuming crops contaminated with the nanoplastics can accumulate in the human body. These accumulations can cause the damaged cells, ultimately leading to the health problems. Nanoplastics are often charged. The electrically charged particles move toward the opposite charge. Meanwhile, solar cells can provide electrical energy. My research aims to develop an innovative solution to prevent nanoplastics from penetrating crops. To achieve this, I had to determine whether the materials could be used as non-toxic electrodes. Graphite is a consists of the multiple layers of carbon and has a high density of the heat and electricity. Graphene is the single layer of the structure of the carbon atoms and also has a flexible conductor. But it challenges mass producing pure graphene, so I focused on the artificial graphene and developed a film that mimics the graphene. In this study, I confirmed whether nanoplastics has electromobility, which electrode is optimal for the nanoplastics electrical capturing, how can be mimicked, and whether the graphene mimicking film can be used for inhibiting the penetration of nanoplastics into crops. I prepared a graphene mimicking film called CTCGP or AFCGP by coating graphene powder onto silicone tape or agar rows. And then I confirmed the firm's electrical conductivity by observing for bubble formation on its surface when electrically was applied to the film in the solution. Also, I used the film as an electrode to examine the electrical mobility of the fluorine nanoplastics. Lastly, I tested whether the films with a low voltage to prevent nanoplastic in the soil from penetrating into crops. I planted lettuce in the potting soil contaminated with the fluorescent nanoplastics and applied each film with the 9 volts. So, I examined the capture of the nanoplastic in the soil by the film, the penetration of nanoplastics into plants in the absence of the electricity, and the inhibition of the nanoplastic penetration in the roots by the film. As a result of the checking the electrical mobility of the nanoplastics by using copper plates, lead wires, or graphite rods, I confirmed nanoplastics migrating toward the positive electrode. It is noteworthy that the copper plates or lead wires were severely destroyed, whereas graphite rods remained stable. It means that the graphite can be used for optimal electrodes. Second, I confirmed whether the graphene mimicking film has an electrical conductivity whereas the fluorine nanoplastics have been charged. The results showed that the fluorine nanoplastics were detected on the surface of the graphene mimicking film. Third, I determined whether the nanoplastic in the soil could be captured by the graphene mimicking film supplied electricity. As a result of observing the film surface under the fluorescence microscope, I could detect many nanoplastic particles on the surface of the both film CTCGP and AFCGP. It indicates that CTCGP and AFCGP can effectively capture nanoplastics. Finally, I investigated whether the electrically supplied film could suppress the penetration of the nanoplastic into crops. The number of nanoplastic in the roots was significantly reduced by the CTGP and AFCGP supplied electricity. Therefore, I showed that the film can effectively prevent nanoplastic penetration into crops. Although the graphene mimicking film actively captures nanoplastics in the soil prevents their penetration into crops, agarose films were degraded to the soil moisture and graphene powder was detected from cellophane tape as the time passed. Therefore, exploring moisture-resistant, non-toxic flexible materials and developing a technique to coating them with a graphene powder could enable long-term use, provide the sustainable solution without the additional cost. Thank you for your attention.